Hello everyone, I'm Vaishnav Sudhish, a second year CSE student at VIT Chennai. Today, I'll be presenting the application of finite automata in search engines. So first, let's all ask ourselves what finite automata actually is. Finite automaton, also known as a finite state machine, is the most straightforward machine to recognize patterns and hence finds various applications in it. It is an abstract model of a digital computer consisting of a finite set of states, a set of input symbols, a transition function, and a set of output symbols. Apart from the field of computer science, they are used in various fields such as electrical engineering and linguistics. They are helpful in the design and analysis of algorithms, as well as the development of programming languages and compilers. Going back to the history and development of the automata, it was first presented in 1943 by two neurophysiologists, Warren and Walter. Intense studies, which were conducted in the next couple of decades, resulted in the establishment of fundamental properties of finite automata, like regular languages and their equivalents to regular expressions, which apply specifically in lexical analysis and text searching. Now let's have an overview of finite automata in search engines. It involves a process starting from which a search query is entered. The engine creates an automaton to match it against documents in its database. Automaton searches for exact matches or more complex patterns in its database using string matching and pattern recognition. Now let's view the two phases of finite automata. In the external point of view, finite automata retrieve relevant documents effectively based on user queries. But if we look at it internally, they are mathematical models that perform string matching and recognition of patterns. Now let's have a deep understanding of how search engines actually work. They generally work in three steps: crawling, indexing, and ranking. In the crawling process, spiders and bots of search engines discover updated web content on every known website. This content, after discovery, is gathered and indexed. The index results are finally ordered and appear on the result page. The ordering is done based on ranking algorithms. The search engine has a variety of components, which includes programs such as web crawlers, indexers, and query processors, along with a ranking algorithm, user interface, database, and web server. A web crawler systematically browses the internet, collects data, and creates a searchable index from web pages. An indexer stores the collected data to make it easy to search by creating an index of all the words found in the content, along with their locations on the web pages. A query processor processes user search queries and matches them against the index created by the indexer. Now, a ranking algorithm is very crucial in this process, which is used to rank the search results in the order of relevance, which includes keyword relevance, page quality, as well as user engagement metrics. A user interface allows users to input their search queries and display the results. It is typically a GUI. An extensive database that stores the index web pages and their associated metadata is also used. So the metadata can be a URL or any link. A web server hosts the search engine and serves users' web pages and search results. Now, let's discuss the benefits of using FA in search engines. Finite automata allow for efficient pattern matching and string searching, which speeds up the search process and improves the response time. They can be used to optimize queries, reducing the number of unnecessary comparisons and improving the accuracy of the results. They can be compressed to minimize storage requirements, making it easier to store and process large volumes of data. They can be easily scaled to handle large amounts of data, making them well suited for search engines that need to process vast amounts of information. They are flexible and can be adapted to different types of searches and data structures, allowing search engines to tailor their algorithms to specific needs. Search engines use complex algorithms to retrieve relevant results for a user's query. These include Google's autocomplete feature search suggestions, the Aho-Corazic algorithm, and algorithms in Apache Lucene. Google's autocomplete feature suggests possible search terms based on the characters the users have entered so far. It uses a trie data structure, which is used to efficiently store and search for strings. A popular algorithm, which is the Aho-Corazic algorithm, is used by several search engines to search for multiple patterns in a given text efficiently. It works by building a finite automaton from a set of practices and then using a robot to search for all occurrences of patterns in a given text. A widely used search engine library, which is the Apache Lucene, provides tools for building search indexes, searching those indexes, and retrieving search results. Lucene uses algorithms and techniques, including this finite automata, to efficiently search and retrieve information. These algorithms take into account various factors such as the relevance of the web page's content, the quality of the web page, and the popularity of the web page, among other factors. The process starts with the search engine spider crawling the web to collect information on websites and pages, then indexing them based on keywords and phrases that are relevant to the content. When a user enters a query, the search engine applies a ranking algorithm to sort and display the most relevant pages first, based on a number of criteria, including the relevance and quality of the page's content, the popularity and authority of the site, the user's location, and other factors. The goal of the search engine is to provide the user with the most relevant and useful information possible. Now let's look at some examples of search engines which use finite automata. Google Search uses finite automata to quickly match search queries with relevant web pages. It uses a trie data structure to store keywords and their associated web pages. Microsoft search engine, Bing, also uses finite automata for the same purpose. However, it uses a variant of the Aho-Corazic algorithm for keyword searching. This allows it to handle complex search queries and return results quickly. The Yandex search, which is based on a popular search engine in Russia called Yandex, uses finite automata to match keywords with web pages in its search index. It also uses a variant of the Aho-Corazic algorithm, but also uses a deterministic finite automaton to index web pages, which allows it to quickly search for relevant pages. Now let's compare the finite automata with other technologies in search engines. These include regular expressions, keyword-based search, natural language processing, and machine learning techniques. Regular expressions are similar to finite automata in that they're used to recognize patterns in text. However, they're more powerful than FA as they can express more complex patterns. They're used to search for patterns such as email addresses, phone numbers, and URLs. Keyword-based search is the most common type of search, and they work by indexing the content of web pages and then searching of the keywords entered by the user. However, they often return a large number of irrelevant results. The natural language processing technology can help to improve the relevance of search results by allowing computers to understand human language. It is used in search engines to better understand the intent behind a user's query. Machine learning techniques improve the relevance of such results as well. Machine learning algorithms can learn from user behavior and adapt to improve the search results over time. This can help to reduce the number of irrelevant results and provide a better user experience. Now let's come to the strengths and weaknesses of FA when used in search engines. While it has strengths such as speed, memory efficiency, flexibility, as well as accuracy, it has weaknesses such as limited language processing, limited context awareness, and maintenance. Finite automata are very fast in processing input strings, making them suitable for use in high-performance search engines. They use minimal memory compared to other search engine techniques, making them suitable for searching large databases. They can recognize patterns in various types of data, including text, images, and audio. They are highly accurate in recognizing patterns, which is important for delivering relevant search results. However, they can only recognize simple patterns and regular expressions, making them less suitable for complex language processing tasks such as natural language understanding and machine translation. They do not have the ability to understand the context in which a search term is used, which can result in irrelevant search results. They are not well suited for processing unstructured data, such as free-form text, making them less effective in search engines that rely on natural language processing. About the current and future prospects of FA in search engines, some of the key points mentioned are keyword search, in which match search queries with keywords in web pages, which improves the accuracy of search engine results as well as its speed. The autocorrect and suggestion feature is extremely helpful in improving the search experience and accuracy. Other features such as spam filtering, semantic search, natural language processing, as we discussed, as well as personalization, also help in this improving the quality and relevance of search engine results. The application of finite automata in search engines is just one example of the many ways in which computer science continues to advance and evolve. As we continue to develop new algorithms, techniques, and models for processing and analyzing data, the implications for the future of computer science are profound. One of the most significant implications is the potential for continued improvements in the speed and accuracy of search engines and other information retrieval systems. By using finite automata and other advanced techniques, we can better understand and manipulate complex data structures, making it easier to find and analyze information in real time. Another implication is the increasing importance of machine learning and artificial intelligence in computer science. As we continue to develop more powerful algorithms and models for processing and analyzing data, we'll be able to create more sophisticated and intelligent systems that can learn from their environments and make increasingly accurate predictions and decisions. Additionally, the use of finite automata and other models in search engines has implications for natural language processing, robotics, and other fields that require the processing and analysis of complex data structures. By developing new algorithms and techniques for analyzing and manipulating these data structures, we can unlock new insights and capabilities that were previously impossible. In conclusion, as we continue to develop such new techniques and models, the potential for innovation and discovery in this field is truly limitless. And with this, I'll wrap up the presentation. I thank all of you for taking this time to watch it. And here are the references which I used for creating this presentation. I hope you all enjoyed watching this video. And once again, thank you.